Okay, welcome. We're doing another quick tutorial today on sort of the fire partitions, fire barriers, firewalls within the International Building Code and how that relates to the Underwriters Laboratories UL assemblies that you kind of typically see or or reference within architectural drawings. I think first and foremost within kind of our office code folder we have IC International Code Council tutorials. Now this one I'm going to walk through is some of the stuff I pulled from the 2015 version of the International Building Code. I'm going to be looking at these different types of rated walls and walls rated per table 601. Okay. Sometimes there are a lot or potentially other requirements for rated walls. A lot of that will probably show up in possibly the special detailed requirements, of Chapter 4 of the International Building Code. For example, Section 420 covers a lot of the residential occupancies that you'll run into. So for example, when you're doing dwelling units, the demising walls, the ceilings, the corridor walls, all these things have to be built as fire partitions. Okay, just to make you aware of that. Dipping in, the International Building Code kind of starts you out, Chapter 6. They basically want you to determine your construction type 1 through 5, and then sometimes whether or not that's 5A or 5B, which is, if you're not familiar with any of this, it works like this. Type 1 sort of the non-combustible, very expensive type of construction, but you're allowed to build the biggest buildings with the most number of stories, and it sort of gets cheaper as you move down the board. That's not always true, but in general it is. So for example, type 5, those are your combustible buildings, aka the buildings made out of 2x, wood, trusses, wood floors, all of it. It has the ability to propagate fire. It will act as fuel for fire, right? That's what kind of being a combustible product in general means, as opposed to concrete or steel or aluminum, which doesn't really necessarily burn on its own. Now, that isn't to say that under fire, obviously steel, for example, loses a lot of its strength very quickly when it's exposed to a lot of heat, but it doesn't necessarily burn. Okay, so let's say we're doing the typical 3-story R2 building. That's almost certainly going to mean we're in construction type 5A, which means my primary structural frame, bearing walls. Again, you kind of get bumped to other sections of the table, floors and roofs all end up needing to be rated as 1 hour. Okay, from there, let's go ahead and talk a little bit about fire barriers, fire partitions, and firewalls. Firewalls are the most restrictive. Firewalls basically take one continuous building and divide it into 2 separate buildings. So, for example, the reason that we would use a firewall is if the allowable building area per floor exceeds what we are allowed to build in your area tables. Okay, so let's say that we were looking to chapter height and area. I'm going to use the 2018 version of the building code because it's super easy to understand. Okay, so let's keep it with 5A. So in R, now again, this is non-sprinkled, sprinkled 13R, and then fully sprinkled, I believe, if I'm reading this right. So you're kind of limited to a certain amount of height, and you're limited to a certain amount of area. So again, let's see, building area, that's still height. Let's keep going. There we go. Here's our building area. So for an R2, sprinkled multi-story or sprinkled 13R. Let's keep it at 13R for a residential sprinkler system. That's a lot cheaper than a full 13 and very common. I'm allowed 12,000 square feet per floor. Now, I haven't used my frontage increase, but let's say for the sake of argument, I have a building that's 24,000 square feet per floor. I could put a firewall theoretically in the theoretical middle of that building. I can bisect it, and then I would be allowed per building code to treat it as two buildings, one each building having an area of 12,000, so 24,000 divided by 2. Okay, that's the main reason that we use firewalls. Firewalls are also required to meet a lot of requirements. They must be built in a certain way, but in general, a firewall needs to start at the concrete of the first floor or the concrete of the basement, whatever it is that touches dirt, and that 2-hour or more rating needs to go all the way as a minimum to the underside of the roof deck, and it cannot be broken, right? You can't start and stop. Let's say we're doing it, with 2 layers of shaft liner and using UL U347, right? I can't start and stop that. I am allowed to penetrate it. I am allowed to have a certain percentage of openings, but those openings and those penetrations need to be treated in a very specific way. Okay, firewalls need to have certain rules about, again, it's sort of where the openings are located and then how much rating that opening theoretically needs to have. This is code talking about the underside of slab, why you can stop it at the underside of slab, but then you need to have a rating for the roof, like 4 feet each side of the roof, to allow you to not have the firewall stick up 30 inches or whatever it is that code requires above the roof deck. But in general, there's firewall discussions about if it happens to sort of bisect a building and then become an exterior wall. There are rules on that, rules on how you have to rate the ceiling adjacent to these firewalls. And again, this is very specific stuff, and you need to understand in a meaningful way all the portions of the firewall and everything that you do to that firewall. It's also probably worth mentioning that the firewalls have a Chapter 7 section that will supersede the fire resistance rating that you might find in other sections of IBC relative to rating for firewalls. Just make sure you double check your occupancy group and that fire resistance rating here in Chapter 7 as well. Okay, so firewalls are the most robust wall that you can build for the International Building Code outside of let's say, I'm not going to get into like the blast resistant walls, those walls that are used for hazardous materials. I'm not wading into that for this. For the sake of argument, for most folks, for most architects, the firewall is probably the most robust wall you're going to build. And the key factor here that divides a firewall from, say, a fire barrier, other than its continuity, is that it turns one building into 2 or 2 buildings into 3, and so on and so on and so on, depending on how many firewalls you have in a building. You're allowed to have multiple firewalls in a single contiguous building. For the sake of code, you can bisect it up. Make sure you're checking things like your horizontal egress. Among other things. I see a lot of architects make this mistake about not locating stairways right next to firewalls. I'm not going to get into it for the sake of this argument or for the sake of this talk, but it's horizontal exits. Vis-a-vis considering an exit where you pass horizontally through the firewall. You're not allowed any section of any firewalled area or any building defined by a firewall can't have more than 50% of its exits for a given floor move horizontally into another building, but you are allowed to do that to a certain degree. Fire barriers. This is a good argument. This is sort of less restrictive than a firewall. So here's a good example of a firewall in construction that you can see that the shaft liner, the rating of that firewall, is totally continuous all the way to the underside of roof deck from the slab or foundation. Well, when you do a fire barrier is allowed to sort of stop at the underside of the floor or roof deck, and then you can sort of pick back up if you had multiple floors up above, or if you had, like, say, an attic space, you could pick back up in the attic. But basically, the interstitial space needs to be protected with drywall in a fire barrier, but you are allowed to a certain degree to have that fire barrier stop and start at, I think the general logic here is solid objects like roof sheathing. This is a good drawing because it's different than a fire partition, which leads me to fire partition. So if I was just doing a fire partition, the rating would be allowed to stop at the ceiling, right? So I could have that drywall stop here, the ceiling, and then this interstitial space, the concealed space, the truss space, whatever you'd like to call it, would not need to be protected or blocked like you do on a fire barrier. That's one of the main differences between a fire barrier and a fire partition, which also leads me to why a fire partition is more protective, or provides you more protection or a more robust rating or safer rating than a fire partition. That's really one of the main differences between those two. You're also, you can have a fire barrier, look at continuity. So within fire barriers, just in general, people draw things that are very similar to fire barriers, but they're not quite fire barriers. A couple of good examples of those would be stair shafts, or say like a shaft enclosure in general for like a trash chute or something. They have special exceptions within the building code for stairs. For example, so you'd say, I have a 2-hour stair wall that needs to have fire barriers. Well, those fire barriers are continue all the way up to the underside of truss bearing for my roof. So they basically can have a 2-hour cap. So that fire barrier from a stair doesn't have to go all the way to the underside of roof deck. So just bear in mind that sort of within the scope of fire barriers, there are exceptions to how robust that fire barrier needs to be. You're allowed to build a little bit less in certain when you're doing certain assemblies, basically. Fire barriers also limit the amount of openings that you can have in them, unless you're providing a full sprinkler system. Just bear that in mind. Windows, doors, all these things add up to the maximum allowable opening any fire barrier can have. So just be cognizant of that. Lastly, that kind of leads us to fire partitions. Fire partitions, basically, this is, you get a little bit of overlap with that section 420 that we talked about earlier, where you can have basically rated walls and rated ceilings, but they don't have to basically have drywall in the concealed, interstitial, or truss space areas. They are effective enough in the eyes of the building code. Basically, they end up saying fire partitions are not always required to be continuous through concealed spaces, whereas fire barriers are required to be continuous. That's the primary difference. So there you go, a little bit of code commentary for you to sort of reinforce what we've just talked about. Now, I do want to point out that per table 601, when you see these 1-hour ratings, people aren't necessarily keyed into okay, is that 1 hour a fire barrier? Is it a fire partition? What is it specifically? The interesting thing about this, these ratings, for example, is that they aren't specific to either one. And the code surrounding this table in Chapter 6 kind of dives into that in detail. It's kind of hard to summarize, but the basic premise here is that these ratings from 601 are there to protect the structural frame. Okay, the building elements, or in case of, say, a 5A wood building, the sticks that hold the building up. So these guys aren't necessarily, they don't necessarily require you to, by association, limit the openings or even rate the openings that exist in these walls. Okay. You also in Chapter 7 are going to get exceptions for your exterior walls in fire barriers and in fire partitions to a certain degree, where those exterior windows, those exterior doors don't need to be rated either. So just sort of be on the lookout for that. Again, not getting into that for this particular topic, but it's there. Which kind of, there you go. That really, in a very, very brief, very, very quick nutshell, describes the 3 different ways or the 4 different ways in general that you'll be rating a wall or providing a wall rating with the International Building Code. So let's talk about briefly the assemblies, right? So in general, an architect would need to prove or somehow substantiate that these walls are going to perform at 1 hour or 2 hours or 3 hours or 4 hours or whatever it is we say that they are going to perform. So how do we do that, right? Well, you can do performance-based within the International Building Codes. Like, for example, if I do an 8-inch thick concrete wall, the concrete is of certain strength and has certain properties to it, then I can sort of deduce or sort of reference by the building code, and therefore that wall is going to have a 2-hour fire rating. And that can work, but and there's nothing wrong with that. And proving it out like that is okay. There's just something you probably should be aware of that. And as an architect, you sort of own that wall. You hold the liability for that wall. And most architects already hold enough liability. We don't want any more. So we lean on a group of third-party testers that test wall assemblies and then tell us that if a wall is built per their instructions, that wall is going to perform to a certain hour rating. Specifically, what is that? Well, most of the time, there are a couple different rating agencies, but the one we use predominantly is the Underwriters Laboratories. What is the Underwriters Laboratories? Well, they provide a website. You have to sign in, and you can look up fire rated walls, floors, beams, columns. You can delve into that, and you can pretty fairly quickly find kind of what wall or floor that you're looking for. So let's say I'm looking for a wall or a partition. I want it to be made and protected with wood, gypsum board, and that kind of narrows it down. I need the hour rating equal to 1 hour, less than 2 hours. You can even filter it by an STC rating or sound transmission classification, I want to say, which is all well and good, but typically not used for this. If you want to talk about sound, you can use the sound books. So anyway, getting off track. Basically, we pick a wall. Okay. Now, why do we pick one design versus the 20 others or whatever it is that's offered to us? Well, a lot of it has to do with kind of the materials that they allow you to use in the wall assembly. Like, so for instance, number 5, right? I don't want them to just allow mineral wool or rock wool insulation because it's rather expensive. I want to be able to use fiberglass batt insulation because it's a lot cheaper. So I'll go down and check 5A. Fiberboard sprayed, 5C, bats and blankets. Require resilient channels, mineral wool, bats and blankets. And I basically confirm somewhere in all this mess that I can use the insulation material that I want to use. Okay. It's probably worth noting, as a kind of a final thought, that within these UL assemblies, I don't know if I want walls and partitions. I wonder if I can find, there we go, that cleared it out. Let's do a roof ceiling real quick. Same hourly rating. Stick to gypsum board. This website doesn't want to work quite right for me. There we go. Which, that's what I'm looking for. So let's do a wood structure. Perfect. Okay, so let's say that we're picking a roof, right? So I'd like to find a roof structure that allows me to put the insulation on the underside of the, or I guess the top side of the ceiling. I don't want to have to put it on the underside of the roof deck, which is a harder install. But you also kind of want to be looking out for some of the other things in your fire rated assemblies, specifically some of the mechanical devices. So let's say we're looking at 4 and 5, right? These guys, this entire UL assembly is dedicated to, and all of us are these dampers. The Underrated Laboratories has tested this fire rate assembly with all these damper products. So if your mechanical engineer wants to find some, a different plenum box or something that isn't necessarily in this huge list of suppliers, you're going to have to work with them to find a UL assembly that meets your requirements and allows the contractor and the mechanical engineer to put the piece of equipment or pieces of equipment in your assembly. Just bear that in mind, just food for thought on that issue. So yeah, there you go. That's kind of why you see Underwriters Laboratories, ULs for all these rated assemblies that kind of probably almost certainly stuck in an architectural drawing package. They want to know, they want to be able to prove or sort of shift the liability away from themselves onto Underwriters Laboratories and the contractor to say that this wall is going to perform in a certain way and not burn for, or at least resist fire for a certain amount of time in a certain way. That's why they're there, right? And then why they're so blessed, many of these things has to do with a bunch of manufacturers having their particular product tested in one of these assemblies, and so you end up with just a ton of them. Manufacturers pay a lot of money to have their products tested in these things, and sometimes you'll have like little gotcha moments, like for example the I don't know, we can give a good example. Let's say Huber zip system, right? Huber zip system has a sandwich panel where they do, a quarter inch or a half inch of sheathing or whatever it is, and then a half inch of foam insulation. Well, that product has a flame spread on their foam that doesn't really let it be used or work with certain UL assemblies. They had to kind of come up with their own special UL assembly to get that product to meet Underwriters Laboratories performance rating. So they have like their own very special UL assembly, and really it's the only thing that makes it special is that they, for example, on an exterior wall require you to use mineral wool or some other additional fire resistant material. I can't name all of them, but I know rock wool or mineral wool is one of the things, instead of being able to use fiberglass bats, that because they have to do that, that ultimately that's going to make your building more expensive. So just that, things like that buried within the Underwriters Laboratories are things you kind of in general want to look out for. So if they value engineer or they want to switch a product on you, sometimes you have to go back and double check that that product has been tested with the assemblies that you've chosen. It can actually get quite tedious or complicated to make sure that you've got that you're coordinated on these things. So that's that. Yeah. In any event, I hope this has been helpful. Hopefully I haven't left out too much critical information that is totally relevant to this tutorial, and I wish you the very best of luck. Thank you.